Yeah. Example 2. Under relative velocity, train is traveling along a horizontal rail at 54 kilometers per hour, and rain is falling vertically with a velocity of 5 meters per second. Find the apparent velocity of the rain to a person in the train. Now, the velocity of train is equal to 54 is given to be kilometers per hour. Now, and velocity of rain is given to be 5 meters per second. So we need to convert this kilometers per hour to meters per second too, in order to be in the same units. Now, from kilometer to meter, so we need to multiply this 54 by 1000. So it will be 54,000. Then to convert hour to seconds, is per hour. So that is 60 multiplied by 60. That is 3,600. So you need to multiply 54,000. Oh no, 54,000 divided by 100. So I do that calculation for me. What is your answer? 54,000 divided by 3,600. So you can see that your answer is 15. That is where we get 15 meters per second. Is that okay? Now, let's now look at the diagram now. So from here now, let OB represent velocity of rain, which is going to be 5 meters. So this is 5 meters per second. Then let OA velocity of train. So this one has been converted to 15 meters per seconds. Is that okay? 15 meters per seconds. Now, this is what we are looking for now. Is that okay? So the velocity of rain relative to train. So this is velocity of rain relative to train. It will be what? AB. This is the line AB we are looking for. Is that okay? So it will be equal to velocity of rain minus velocity of train. Now, velocity of rain, which is OB, then minus OA is equal to what? AB is equal to AB. Now, to now find this AB, we use the Pythagoras we have been using before. Is that okay? This is line AB we have to find, right? So this now will be equal to AO square plus OB square, which is 15 square plus 5 square. So 15 square is 225. From 5 square is equal to 25. So if you add 225 plus 25 is equal to 250. Now, in order to get AB that we are looking for, this line AB, so you need to find the square root of both sides. Now, square root of AB square will give AB. Then square root of 250 will give you 15.8 meters per second. So that is the magnitude. This the length of this AB. Now, this angle with relative to this particular line O, is that okay? Line OB. So this angle theta represented as theta. So the tangent of this angle, so the tangent is what? Opposite over adjacent. So the opposite here, the opposite to this angle is 15. So adjacent will be what? 5. So opposites, which is what? 15 divided by 5. 15 divided by 5 is equal to 3. That is why we have a tan theta is equal to. So theta is opposite over adjacent. So opposite to this angle is 15. Is that okay? Then divided by adjacent 5. So 15 divided by 5 is equal to 3. So that is why tan theta is equal to 3. Then to find the value of theta, just divide both sides by tan. So that is why theta is, then 1 over tan is equal to arc tan. So that's why we are having arc tan 3 as the value of this of this theta here. Is that clear? So that is that about relative velocity. So, but before you go, I would like you to practice these examples at this class work. Number one, two trains are moving on lines which cross at right angles. So one at 40 kilometers per hour, the other at 50 kilometers per hour. So find the velocity of second train relative to the first. So they are moving on lines which cross at right angle. So this one, they are not on the parallel, they are not on the parallel lines. Is that okay? So you use the second method. Then the second one too, one ship is sailing due east at 24 kilometers per hour and another ship is sailing due north at 32 kilometers to the first. So this one, this example 2 is also like this classwork 2 is also like example 1. So just follow the steps from the example and you will get it. So that is that relative velocity.